Okay, we're going to work out the least squares regression line of best fit. Now it's more accurate than doing it by eye. We're going to use it by calculations. What we already have is the mean for the x, mean for the y, standard deviation x, standard deviation for y. And the x is the height and the y is the arm span of these swimmers. So in order for us to get that equation for the least squares regression line of best fit, or least squares line of best fit, all we need to do is follow 3 steps. The first step is we're going to find the gradient, and that's this formula here. The slope equals r, the correlation coefficient, times standard deviation of the y-scores divided by the standard deviation of the x-scores. And then step number 2, we're going to work out the y-intercept b. b equals the mean of the y's minus the gradient times the mean of the x's. And finally, step number 3, we're going to put it into this formula, y equals mx plus b, to get that equation, the equation for the least squares line of best fit. So let's go through these steps. So we have all this information, so we can put it in here to work out the gradient. So let's go ahead and work that out. So let me just put a little boundary here. Okay, in order to work out the gradient, m is equal to r, the correlation coefficient, which is 0.99. We're going to multiply that by the standard deviation for the y-scores, which is 5.11, all over the standard deviation for the x-scores, which is 4.235. Use 3 decimal places, because if you use 2, you will get another answer. So that's for gradient now. Put that in your calculator. 0.99 times, brackets, 5.11 divided by 4.235, close brackets. The gradient will be m is equal to 1.195, and that's the 3 decimal places. Okay. m equals 1.195, the gradient, 3 decimal places. So we got gradient. Now the next thing we want to do is find the y-intercept, which is b. So let's write this formula up here. So b equals the mean for the y-scores minus the gradient times the mean for the x-scores. So b equals y, the mean scores, the mean for the y is 190.125, 3 decimal places. 190, 125, 125. Take away the gradient, which is 1.195. I'll put that in brackets. 195 times the mean for the x-scores is 191.25. Okay, so b, the y-intercept, equals, on your calculator, 190.125 minus brackets 1.195 times 191.25, close brackets, hit the equals, and you're going to get a value for b of, it's going to be negative. It's going to be negative 35.2, 3 decimal places, 419. If you do 2 decimal places throughout, you will get a slightly different answer. Okay, there's our y-intercept, there's our gradient. Now all we have to do is work out the equation for the least squares line of best fit. And to do that, we just take these 2 guys and drag and drop them into that y equals mx plus b. So let's put it straight in there. So y there equals m, the gradient, 1.195, 1.195 x plus, well actually it's a minus, so I'm going to correct that. We have a minus 35. There's that minus, drag it down here, minus 35.419. Okay, now I want to change the x and y, the variables that we labeled, and change them into height and arm span. So let's say that our height, let's call height and arm span. What shall we denote them? Well, height, we can use h. Let's use h. and arm span, let's call it S for arm span. Okay, and they're both in centimeters, and the height will be the X value. That'll be the X value, and the arm span will be the Y value. Okay, so we've got the Y value. So arm span, which is S, replace the Y with an S. So S equals 1.195, the gradient, and X is the height, so we put a H there, minus 35.419, and that is the equation for the least squares regression line of best fit. S, the arm span, equals 1.195, H, the height, minus 35.419. There you go. Hope that helps.